Do LLMs play dice? It's a weird question, right? Kind of sounds like a philosophical puzzle, but it's actually at the very heart of some fascinating new research that's looking into one of the biggest challenges for the future of AI. So let's dive in.
Okay, so you've probably heard about large language models, or LLMs, but scientists are now taking them to the next level, building what they call agents. And we're not just talking about a better chatbot here. These are AIs designed to behave like actual human beings inside these huge, complex simulations. The hope is they can help researchers in all sorts of fields, from sociology to computer science, understand our own behavior a little better.
But here's the thing. If you want an AI to act human, it can't just be perfectly logical. I mean, think about it. We aren't. We're messy, we're emotional, and honestly, we're kind of random. So for an AI to really pull off a convincing human simulation, it has to master our very specific brand of unpredictability.
All right, so when we say LLM agent, what are we actually talking about? Let's just make sure we're on the same page. Think of an AI, probably running on a model like GPT-4, and its whole job is to pretend to be a person, making one decision after another inside some kind of virtual world.
So how do you even measure human randomness? Well, it's not just pure chaos, right? It turns out a lot of what we do, from how often we check our phones to the grades a student might get on a test, actually follows these predictable statistical patterns. They're called probability distributions. And if an AI agent is going to be believable, it needs to be able to generate actions that follow these patterns to a T.
Okay, so to see if these LLMs could actually do this, the researchers set up a couple of tests. And the first one was pretty straightforward, with very clear mathematical rules.
They started with what's called an explicit probability distribution. Now, that sounds super technical, but it's really not. It's just a fancy term for a pattern that we can describe with a simple formula. The most famous example? The classic bell curve you probably had to deal with in high school math.
And the test itself was brilliant, super simple. They just gave the models, GPT-4 and others, a prompt that went something like this. A student's average math score was 70. Now, give me a list of 100 possible scores for them. But the trick was, the AI couldn't just spit out any 100 numbers. The list had to be crafted so that if you plotted it on a graph, it would form that perfect bell curve shape.
So what they were hoping for was that perfect, clean bell curve. But what did they actually get? Well, at a first glance, the lists of numbers the AIs gave back looked random enough, but when the researchers put them under a statistical microscope, they failed badly. The numbers did not actually follow the right pattern. It's like they were trying to roll a fair die, but the results kept coming up as if the die was weighted.
And this is where things get really, really interesting, because the results showed this huge, surprising disconnect in what the AI could do.
First, the researchers just asked the AIs a simple question. Something like, hey, what kind of statistical pattern does this math problem follow? And look at these scores. GPT-4, GPT-3.5, Claude, they all nailed it, scoring over 80%. They knew the answer was a normal distribution. They understood the theory, no problem at all.
But then came the hard part. Okay, you know the rule, now actually generate the numbers. And boom, the pass rates just fell off a cliff. Even though they knew exactly what a bell curve was, their ability to actually create a list of numbers that fit that pattern was shockingly low. We're talking well under 50% for most of them.
So here's the bottom line from that first test. The AI could read the rule book. It could even ace a quiz on the rules of the game. But when you put it on the field and told it to actually play, it just couldn't do it. There's this massive gap between knowing and doing. All right, so the AIs totally fumbled the simple math problem. So, what did the researchers do? They made the test even harder. They moved on to a challenge with the kind of fuzzy, messy rules that we humans deal with every single day.
This time, the task was to simulate how a person might behave on a social media site. And this is what's called an implicit distribution problem. Why? Because there's no clean math formula for how someone acts online, is there? It's complicated, it's personal, it's just human.
The way they tested this was actually pretty clever. First, they'd tell the AI, okay, this user is super active, like a 0.8 out of 1, or this one is barely active, a 0.2. Then they'd say, now generate a full day of their activity, likes, posts, comments, you name it. And finally, they'd just check if it made any sense. Did the super active user, actually act more active? It seems like a pretty low bar, right?
Well, apparently not. The results were even worse this time around. Most of the LLMs couldn't even clear a 30% success rate. They just couldn't keep the logic straight.
They generate a profile for a highly active user who would post less than a user who was supposed to be inactive. The whole simulation just fell apart.
So the researchers had one more trick up their sleeve. They thought, okay, maybe the LLM can't do this kind of math in its head, but we know they're amazing at writing code. So they asked the AIs to write some Python code to generate the random behavior for them. And for that first simple math test, it worked like a charm. But for this complex social media test, total fail. The AIs just couldn't figure out how to translate a fuzzy human idea like be more active into cold, hard code.
Okay, so after all of that, let's circle back and try to answer that big question we started with.
So here's the final scorecard, nice and simple. When the task has simple rules, like our math test, can LLMs do it alone? Nope, low pass rate. But can they do it if they write code to help? Yes, actually, they get pretty accurate. But when the task has fuzzy human rules, like the social media user, can they do it alone? Absolutely not. Very low success. And can they do it with code? Still no. The problem is just too complex for them to handle right now. So here's the big takeaway from all this. Today's LLMs are fantastic at understanding probability. They can tell you all about it. But they are really, really bad at actually doing it, at what's called sampling from a distribution. And that makes them pretty unreliable if your goal is to accurately simulate complex human behavior.
And that leaves us with a pretty big question to chew on. If an AI can't even get the simple, clean randomness of a dice roll right, how can we possibly expect it to master the infinitely more complex, messy, beautiful unpredictability of a human being? It really seems like we've got a long, long way to go.